As was introduced, my name is Kato. I am from Smart Community Department. I would like to talk about NEDO's approach to high voltage DC power transmission technology. Very pleased to see you all. Now, this is the flow of my speech today. As you can see from here, first I would like to talk about very basic information about DC before touching upon examples of projects overseas in terms of introduction of HVDC as well as R&D. And then we would like to turn our eyes to Japan to give you up-to-date information in Japan as well as NEDO's approach to offshore DC transmission system development project. Before touching upon the results and benefits and outcomes of this project, and then I would like to give you some summary as to challenges going forward. Now, about DC and AC. DC was invented in the second half of 1800 at the same time as AC. Edison, which is for DC, and Tesla, which is for AC. There were two groups fighting for control over the area, which is actually known as fight for current power. Now, AC was easier for voltage change, and therefore it was regarded to be superior to DC, and therefore AC became global standard for many years to follow. However, DC started drawing attention as well as started becoming accepted because of its characteristics. On the vertical axis, you have voltage, and you can see the penetration of DC usage. As you can see, PC, like the ones you use, you take power from AC socket, but inside of the PC, from few volts to few dozens of volts, the AC-DC conversion is happening, and that's what we call as LVDC, or low voltage direct current. Data center is the aggregation of electronic devices, and railway is the basically AC, correction, DC. 1000 volt MVDC is the power that those applications are utilizing. And for high voltage direct current, which is between 125 kV or 500 and above, this is the area called HVDC, which is said to be good for long distance transmissions of power. DC is drawing attention these days, so I would like to give you reasons why using the next page. The reasons is as follows, especially in the MVDC and LVDC area. PV and storage are being utilized more than before, and that's one of the reasons for demand for MVDC or LVDC. And also IoT and home appliances, they are also using DC, and so this is one of the drivers behind more DC. So buildings and microgrids or other limited scope, depending on the combination of the devices, use of DC directly is considered to be more efficacious, and that's the application that we are seeing more and more these days. Now, this is the area of HVDC. Like I said before, long-distance power transmission is benefited if DC is used. So this is a relation between cost and distance comparison of DC and AC usage. In the case of DC compared with AC, you need AC-DC converter, and that is not related to distance, and therefore DC tend to be more costly. However, if the distance becomes longer, the DC requires only two phase, and also the electric poles structure can be much simpler than that of AC. And also in the case of AC, the rectifier devices would be needed if distance becomes longer, and therefore longer the distance of transmission, more beneficial for DC, and also loss of electricity is shorter with DC. So those are the characteristics making DC much more cost beneficially. For example, in the case of overhead transmission line, if the distance is longer than 800 km or more than 50 km, in the case of submarine transmission line, DC is considered to be cost competitive than AC. So in the area of HVDC, PV and wind power or renewable energies, if that is used more in the future, and there will be higher needs for longer distance transmission distance. And one of the reasons for the focus on HVDC is coming from that situation as well. Now, as a last part of my explanation in this section, I would like to give you an explanation about the methods that are used for HVDC. There are differences in terms of AC-DC conversion, and there are two types. One is separation excitation, which is used more commonly, and the other is voltage-sourced excitation, which is growing. Voltage-sourced excitation allows flexible rectifying control or power flow control. And also a black start is possible. So those are the characteristics of voltage-sourced excitation. For example, last year, in the case of earthquake in Hokkaido, blackout occurred. And between Hokkaido and Tohoku, there is a transmission line of DC, but the black start was not possible because that transmission line was based upon separate excitation. However, in the case of separate excitation, capacity enhancement is quite easy, and also electricity loss is quite small. And therefore, we can utilize different methodologies depending on the characteristics of the transmission system, and that's what I want to mention here. So that was a comparison between AC and DC by focusing on characteristics of DC. What is important is there are characteristics and pros and cons of DC and AC, so we need to utilize their benefits so that we can create best mix between AC and DC. But to enjoy benefits of these methodologies, we need to solve some of the technologies. That means we have to do R&D. And also, in order to expand benefits, we need to do more R&D. So those things are also important going forward. Next, I would like to talk about the overseas use cases. This is taken from the homepage of HVDC information taken from the manufacturers. And this is self-excitation, and the other is separate excitation. As you can see, those are now being used in various many parts of the world, and separate excitation is used more, but as you can see, voltage sourced excitation is now increasing, and this is another manufacturer. Similar trends are being seen at the same time. Now, I would then talk about more specific situations depending on the regions around the world. Now, talking about Europe. In Europe, mainly there are two purposes. You is a driver behind the DC. For example, offshore wind power need to be connected to the onshore, so the interconnection line between the two locations is one need. And also in transmission, there are mismatch of consumption market and the generation market. In order to connect these two, high voltage DC is being asked for. So point to point or two terminals is the method that are being used for HVDC interconnections. Two terminal power transmission is quite simple in terms of current flow, and also isolation at the time of accident is quite easy. However, once interconnections or transmission line fails, even if the power generator is healthy, intact, power so generated will not be delivered to the consumption market. So there is been the drawbacks of that. Especially submarine cable would require much longer time to be repaired, so the damages can be quite big. So in the case of HVDC, the next step would be multi-terminal method. And this is one of the topics for R&D at this point in time. This is the page indicating major projects that are happening in Europe at this point in time. As you can see, Best Path, which was carried out between October 2014 to September last year. 8.1 billion yen was the size of the budget for this project. And Promotion is another project in Europe, which started in January 2016, scheduled to be ended in December this year. 5.6 billion yen is the size of the budget for a multi-terminal method. In these two projects, each individually, this is the circuit breaker, for example. The technology needs to be enhanced, and interoperability here need to be brought to the higher level. For multi-terminal, these are the element technologies that are needed, and therefore these technologies are planned to be enhanced during the course of this project. However, system control, which is quite difficult or complicated, shall be raised to the level of medium range instead of going higher. And those are the schemes. Now, this is yet one more example. This is an example in Germany. This is a HVDC project anticipating multi-terminal application. Offshore wind in the north of Germany will be brought to the southern part of consumption market. However, connection between the two locations are considered to be weak, and therefore this project aims to reinforce or harden the transmission line. Initially, two terminals will be used, but that will be done so by anticipating three-terminal methodology down the road. Next is about China. China is a very big landmass, and inland area there are sources of RE, for example, PV and wind and water. There is an area which is abundant with renewable energy sources, but the consumption area is concentrated on the coastal area and also northern eastern part of China, which population is growing. And therefore, between the two locations, land-based long-distance transmission line is required, and that's a need for HVDC. Two-terminal HVDC is now under construction. HVDC introduction started in Europe initially. However, recently, China is accelerating the pace of development. As shown here is the data in 2017. This indicates, well, they have generation capacity, but they have shortage of transmission capability, and therefore renewable energies are not fully utilized. In the case of PV, they say lost solar power or wasted solar power. And in the case of wind power, they say lost wind or wasted wind. If you look at this chart, more than 30% of the PV power is being discarded because of the shortage of transmission capabilities. This is considered to be the second largest cost factor after building facilities, and therefore this is considered to be one of the reasons why high voltage DC is growing at such a higher speed. And this is the abandon rate. 2016 rate was 17%, but 1 year after it was reduced down to 12%. The target is by 2020 have the abandon rate of only 5%, and that's what they have as a target. During these years, PV power generation would grow by 1.44%, even against more power generated by PV. They will be utilizing more renewable energy, and therefore this target is considered to be very ambitious. In China as well, multi-terminal application is underway. Shown here is the project in the place called Jianbei, which is the northern western part of Beijing. As you can see, 4 terminal is used to connect DC between the two. My impression is that in China, compared with other countries, R&D, early phase of R&D would create actual facilities in the field in order to accelerate the project. So they do trial and error in the field. That's how I feel about the nature of the project in China. Likewise, this project is considered to be commissioned in 2019. I'm trying to get some information on this project, but it's very difficult to gather, and therefore I don't know how far they have gone. But in China, they use actual facilities to raise the level of service in the field. So from the development of technology aspect, they are accelerating what they do. That's how I feel about China. So Europe went on first, and then China is growing at a rapid speed, and all the other countries also, they are doing their own project as well. For example, one example would be in North America, Atlantic Wind Connection project is up and running. In phase 1, off coast of New Jersey, the wind power is generated, and this power will be utilized in this manner. And in phase 2, what they plan is to also connect the power from Virginia, which is southern, down south than the first location. And the phase 3, phase 1, phase 2 facilities, these two will be linked so that big multi-terminal power line would be built, and that is their plan. And also in other area, India and Brazil, they are also having a very big landmass, and therefore long-distance transmission of power is being contemplated. 800 kilovolt or 1100 kilovolt, very high voltage DC is now underway.
So, as I stated, many projects are going on in various countries, and even in international seminars, there are many presentations given about this. I share with you one example. This was announced at the SIGRE 2018. Keynote speech, study committees, and there were 4 workshops, and 2 of them were about the HVDC. So you can see that this is very trendy topics, and these 3 were very hot. The first one is the interoperability standardization going on in Europe. This is the offshore DC transmission, mainly in North Sea. So they are working on the several terminals in the shallow beach of the North Sea. They construct the artificial island and make it as a hub for the transmission of HVDC, and this is a very large-scale concept, realizing around 2050. Second one is the, as I said before, that Brazil, India, and China, they are using the overhead cable to send 800 kilovolt or 1100 kilovolt high voltage DC. And as for basic research, they are currently studying the submarine cables, and including other DC cables. Many studies are going on, especially to improve the performance of these cables for DC. And this is the trend of standardization. There is a Senelec, the group which are working on the standardization pan-Europe, the manufacturers, research institute, and university and research institutes, all working on the standardization in HVDC. So they are working on this to be the international standard. And I was told that they are planning to propose it at the IEC, but it seems like it has been postponed because I don't see it anymore. But even for the HVDC, it is almost a time that any party can propose international standard in this area. So very active research and also standardization works are going on. So we, Japan, should really catch up with them and hopefully can be the leader there. Now, I will share with you some domestic cases. The hot topic of DC is the Shin-Kitahon grid. It started March this year. Originally 600,000 kilowatt, but adding 300,000 kilowatt, now it's almost 1.3 times capacity. This is the first time self-excitation DC transmission. And it is possible to do the black start, therefore. One interesting point is that they are using submarine cables, and they are not using tubes. They are using existing Seikan tunnel and installing the submarine cable in the existing tunnel so that they enable the cost reduction in the construction and also maintenance. And next example is the what NEDO is working right now for DC transmission. So I give you the context of this project, but energy, well, Japan is suffering from the shortage of energy sources, and of course we have to reduce the carbon emission, which means that the renewable energy is going to be the future. And the offshore wind generators are necessary to produce more renewable energy around Japan. So what would be the potential areas for offshore wind farms? This is a survey done by Ministry of Environment. If you look at the nearshore capability, in case of Japan, when we have larger distance to shore, then depths become suddenly big, so that have to be closer to the shore. And also, as you see on the overseas cases, usually the main consumption areas are farther away from the electricity production area. So, Hokkaido, Tohoku, Kyushu, they have wind capacity, but they are away from the main consumption area, and you can't really introduce large-scale wind farms from the beginning, but you can do so gradually, expanding the capacity stage by stage. So you can combine the terrestrial wind farms and offshore terrestrial offshore wind farms by DC transmission method. And also many manufacturers will come in to this type of products, so we have to have a standardization for multi-vendors. So this is a case of 2 terminals and 3 terminal cases. I try to compare the two for the benefits. In case of multiple terminals, in case of failure or accident, you still maintain the transmission so that the reliability is high. So it is also economically beneficial because it will not generate any opportunity loss. And in case of 2 terminals, you can make the system more efficient. And these are the benefits of both cases. But there are some challenges. Controlling overall system becomes more complicated. So you have to develop the methodology to control overall system. And also, in case of accident, it is easier to shut down the line. But in case of multiple terminals, you have to develop the system to shut down the accident lines. And also the efficiency is another problem there. So against these backdrops, NEDO decided to work on the multiple terminal DC transmission system, and also basic research, which would be the platform for the large-scale offshore wind farms. There are two main topics to study. The first one is the system development. First, we have to make a plan which economically viable to connect offshore wind farms near Japanese archipelago sea, and also connecting that to the major consumption area. And we also have to develop analytic models to control overall system. We really have to make the standardization for several vendors to come into the converter and also commuter between the self-excitation and the separate excitation. And these are the DC circuit breaker development example. This one is the installation methodology example. And another one is the new technology to make a platform for offshore, which is suitable for Japanese archipelago. And these are some of the items that we are working on right now. In case of simulation model, we are thinking of step-by-step simulation. So first, we started from the 3 terminals DC transmission system. Conducted the simulation with that analytic models, and confirmed that the quality. So currently we're working on the 5 terminals DC transmission. As for multi-vendor project, Hitachi, Toshiba, these two are currently working on the interface, and we are in the process of devising the standardization specifications. And currently, we have already proposed this technology to IEC, and in the process of discussion right now. As for basic research, the DC circuit breaker was very difficult to be implemented because there was no zero voltage point. Usually, we use current in the semiconductor and shut down the transmission. But if you do it, then the opportunity loss becomes large. So what we are studying right now is to just send the current to semiconductor only in necessary time. And we have already achieved the 3 milliseconds breaking speed. The next one is about the separation joint point in cables. We already created a prototype and are currently in process of long-term test. This one is the improvement of the current facility. We are aiming at reducing the cost. So far, we install cable one by one, but now we are installing 2 to 3 different cables. And usually we have pressure-related problems, but we solved that. This is the platform for offshore wind farm. Near archipelago, different from Europe, we have earthquake, typhoons. So the platform should survive these vibrations. And these are the platform we devised. And this is called the suction start method. And so far, we've been satisfied with the result. This is a platform specific for the Japanese archipelago, near shore platform. So cost reduction has been already achieved in these projects, and DC and AC cost comparison has been done. So this is a route of the transmission. These are the comparison of the two. So far, we are still in the process of calculation, but against the AC, the DC can reduce the cost by 20%. So lastly, this is a future challenge. This project itself complete within the end of this year, and we have been conducting the digital simulation based on the ideal condition. So in the future, we have to study the actual systems working in the actual environment, and hope to improve the performance of the multi-terminal DC transmission system. So NEDO will continuously working on the study to improve the quality of the offshore wind farm and improve the performance of the multi-terminal DC transmission, so that we are going to have a best mix available for Japanese electricity world. Thank you very much. Thank you. So let's start the question and answer session. Time is rather limited, so I just entertain one question. So one question from the floor. Japanese R&D, what is the level of the R&D in comparison to overseas study? Is it ahead of them or behind? I've shown you this. These are the European projects, and this is a target of the European project. So for multi-terminals project, there are 3 points to cover. System control, overall system control, including protection, and also interoperability is next one, and also circuit breaker is the next one. And we are in the same level as European research in 3 areas. Both Europe and Japan, we haven't reached to the complete model yet. So we will continuously work on this and have to make it as the actual model. And otherwise we can make use of what we have studied so far. So we really have to work on the next project. Thank you very much. Then this ends the question and answer session. Thank you very much.
ありがとうございました。